I'm going to be working the solutions to 2.1, which is the section on the derivative and rates of change. So we'll start out with number 1. All right, we have find the slope of the tangent line to the parabola y equals 4x minus x squared at the point 1, 3. And it says for part 1, we want to use definition 1. Now definition 1 appears in the book. They're referring to definition 1, which is on page 75, which is that the slope of the tangent line, I'm going to put m tan, is equal to the limit as x approaches a of f of x minus f of a over x minus a. All right, we'll start with that and then we'll do the other one. So whenever we're looking at our parabola over here, we first are going to replace the y with f of x. This is going to be our function, f of x. And here we're going to identify what a is. A is the x value that we are going to be approaching, and here you can see the x coordinate of this point is 1. And of course, this is what you would get if you plugged 1 in. So if you plug 1 in, it should spit out 3, which it does. So that's f of a, or in this case, f of 1. All right, so let's go back to this. This should be equal to the limit. I'm going to replace all my a's with 1. Here, f of x doesn't change, minus f of 1 over x minus 1. And this is equal to the limit as x approaches 1 of f of x. Let's actually replace f of x with what it is. So what is f of x? It's this function right here, 4x minus x squared, minus f of 1, but we already know that f of 1 is 3. So this is 3 over x minus 1. And I'll just clean that up a little bit. That's equal to the limit as x approaches 1. Let's see, I can do 4. No, I can't do anything there. I'll just put it in descending order. I don't have to do this, but I will, over x minus 1. All right, now we can check real quick. If we were to let x go to 1 right now, we would get negative, 1 squared is 1, so we get negative 1, then plus 4, and then minus 3 over 1 minus 1. We would get a form of 0 over 0, which is bad. So we need to do some algebra now. So this is equal to the limit as x approaches 1. All right, I'm going to need to try and do some factoring up top. So depending on how comfortable you are with this, let me try this. Negative x and x. Let's see, negative 3 and positive 1. Let's try that. Negative x squared, good. Minus and minus would be plus 3x, and then another x in here, so that would give us 4 x's. Then 1 times negative 3 would give us negative 3. So that's the correct factorization. On the bottom, I have x minus 1. Now we're almost to the point where we can cancel, except that we notice that these two are off by a sign. So what I will do is factor negative out, and that would change that to positive, and that would change that to negative. That's really a negative 1, but I'll just put negative there. And then these factors cancel completely, and we're left with limit as x approaches 1 of just what was there, x minus 3. And as we let x go to 1 here, just direct substitute, we get negative 2. Now I want to make sure, were they asking for the slope or the, yeah, the slope. Okay, so for part A, this is all part A. We're asked for the slope of the tangent line. So the slope should be negative 2. Now for part 2, they want us to use equation 2, which is a different formulation of the same thing. We should get the same answer. So for part 2, we're going to use equation 2, and that says that the slope of the tangent line is the limit as h goes to 0 of f of x plus h minus f of x all over h. All right, so let's see what happens when we use this formula instead. Now we still are going to have to figure out, I'm sorry, I put x instead of a there, I believe. Hold on. Yeah, f of a plus h. I'm thinking I'm already a section ahead, sorry. There we go. All right, so all we're gonna do now is remember a is 1, so I'm gonna go limit h goes to 0, f of 1 plus h minus f of 1 all over h. Now we do limit as h goes to 0. All right, 1 plus h gets plugged into the function f. So I replace this with 1 plus h and that with 1 plus h. So I have 4 times 1 plus h minus 1 plus h, that quantity squared. That's this. Minus f of 1, we already know f of 1 is 3, all over h. And you could check for yourself if you let h go to 0 right now. If that goes away and that goes away, we will get 0 over 0. So at this point, what I will do is I will expand out the numerator. I'm going to just multiply this all out. 4 gets passed through, and then I expand this. Just make sure you remember that when you expand this, whatever it is, you're then going to distribute a negative to each one of those. So I should get 4 plus 4h. That's this. Then minus, I'll go ahead and expand it all first, and then I'll say minus 3. Then all of this over h. So if you do 1 plus h times 1 plus h, you get 1 plus 2h plus h squared. But then we'll have to pass the negative through. So we get limit h goes to 0, 4 plus 4h minus 1 minus 2h minus h squared minus 3 all over h. And good things are about to happen because I have 4 minus 1 minus 3, that's 0, it's gone completely. I can put these two together. So I should be at the point where I have limit as h goes to 0. 4h take away 2h is 2h. I still have minus h squared and then all over h. And the whole goal of this is to try and get this h to go away because that's what's causing the division by 0. And we can see that we can do that by factoring an h out on top. You know what? Hold on a second. Yeah, all right, so that, and then minus, I pull out an h, sorry, minus h all over h, and then these h's cancel, and we get just this. So limit h goes to 0, and then 2 minus h, and when h goes to 0, you just get 2. Now, I thought we got negative 2 just a second ago. I don't know, my brain is thinking that we got negative 2 a second ago. I guess I'll have to go back and look in the video, but these should be the same answer. Hopefully in the last one we got 2. And they match up, so that's it. We're good. So that's part A. Part B is find the equation of the tangent line from part A. So now what we need to do is use this information, part B, to find the equation of the tangent line. Remember, all we have found so far in both, in part A, 1 and 2, both of them, 2 different ways of finding the same thing. We found that the slope of the tangent line was equal to 2, but we need the equation of the tangent line. So remembering back from college algebra that if you have a point and a slope of a line, it's called the point slope formula, we can use this y minus y1 equals m times x minus x1 to find the equation of the line through that point with this slope. We know the slope of our line, right, is 2, and we know a point on the line, x1, y1, comes from this right here. This is x1, this is y1. So I can just rewrite this as y, take away y1 is 3 equals the slope, which is 2, times x minus x1, but x1 here is 1. And that is the equation of the line. Now, we always like to solve for y to get in what's called its slope-intercept form. So first thing I'll do is distribute the 2 through, 2x minus 2. Then I'll add 3 to both sides. Y is 2x plus 1. All right, there it is. That's the equation of the line. So if I were to draw this parabola, right? If I were to graph it, it opens down because there's a negative here. All right. If we were to go to an x value of 1, it would spit out the y value of 3. And if I were to graph this line right here, that line would just pass right through that point, like that. Now, this is a very loose graph, okay, but that's the idea of what we just did. First thing we did in part A was found the slope of this line. The second thing we did was actually nail down exactly where it is. All right, so number 2, by the way, skip part C because it asks you to graph. I mean, you could go and graph those answers and check, but you're not required to have a graphing calculator, so. Number 2, same exact thing, different function. So see how you do with that. All right, let's look at number 3. For 3, find an equation of the tangent line to the curve at the given point. Wow, this is so similar. Number 3 is so similar to what we just did. I think I'm going to do 4. So I'm letting you do 2 and 3. I'm going to do 4. Because the algebra in number 4 is just a little bit different. X cubed minus 3x plus 1 at the point 2, 3. So let's keep in mind that this is A, this is f of A. So I'm going to first start out by saying, forget this, I'm going to call this f of x. And they are not telling me which formula to use, so it's up to me. I know that the slope of the tangent line is either limit as x goes to a of f of x minus f of a over x minus a, or I can also say it's the limit as h goes to 0 of f of a plus h minus f of a over h. My choice, my choice. So I don't care. I don't care. Flip a coin. All right, I'll flip a coin. I don't have a coin. I'll flip a, the only thing I've got. Here, this. Heads, tails. So heads we do this, tails we do this. All right, here we go. Tails it is. All right, so we're gonna do this one right here. So this equals the limit as h goes to 0. All right, what's f of a plus h? Remember, a is 2, so this becomes f of 2 plus h minus f of a, which is f of 2, all over h. Now that's equal to the limit as h goes to 0. I have to plug 2 plus h into this function everywhere I see an x. That's going to be ugly. 2 plus h cubed minus 3 times 2 plus h plus 1. That's just this minus, what's f of 2? Well, we already said right here, this is f of 2, right? 2, a is 2, so f of 2 is 3. This is just 3. And then all over h. And unfortunately, I have to expand all of this out, which means I have to take 2 plus h and I have to cube it. So maybe I'll do that up here. So 2 plus h times 2 plus h. There's some shortcut formulas for something like this, but I'm just going to do it by hand. I'm going to do those two together first. So I get 4 plus 2h, so plus 4h, plus h squared. And then I multiply 2 through these, and then I multiply h through. So when I do 2 through there, I get 8 plus 8h plus 2h squared plus here to here 4h plus here to here 4h squared plus h cubed. And that's just going to be this top left corner. And why don't I combine like terms? So h cubed, let's see, h squared, 4h squared and 2h squared is 6h squared. 8h and 4h is 12h. And then I have plus 8. All right, so this equals the limit as h goes to 0 of this piece right here, which is all of this junk, h cubed plus 6h squared plus 12h plus 8. I'm going to run out of room. Then distribute minus 6 minus 3h. And then plus 1 minus 3, that's the same as minus 2. All of this over h. Now if we've done everything right, we should be able to get this h to cancel. And I think you can see that 8 minus 6 minus 2 is 0. And everything else you have left there has an h in it. So let me come over here. This is the limit as h goes to 0 of h cubed plus 6h squared. And then I think we have, what's that, 9 h's all over h. Factor an h out of the top. Cancel. And we're at the final step. We're going to take the limit as h goes to 0 of h squared plus 6h plus 9. And if h goes to 0, that's gone, that's gone. All you get is 9. So the slope of the tangent line should be 9. I'm just checking it real quick mentally. Yeah, all right. So now, that's just the slope. We need the equation of the tangent line. So I'm going to use this again. And I can replace y1 with 3. My slope, which is 9. Then x minus x1, which is 2. I can now distribute the 9 through. And now I can add 3 to both sides. Y equals 9x minus 15. There we go. So that's the equation of the line that would intersect this graph at this point and would be tangent to that curve. All right, that was nice. Let's do 5. 5 is just root x. Doesn't look so bad, does it? And they give you the point. 1, 1. I'm going to draw a little quick picture. Here's the point. We're trying to find the equation of the line that runs tangent to this curve at that point. So remember that a is 1 and f of a is also 1, right? But you may as well call that f of 1, right? So these go together and then these go together. So I know that the slope of the tangent line will be equal to the limit. Let me use the first one since I used the other one for the last problem. All right, so we'll do that one. I'm going to replace all my a's with 1. And I'm going to replace f of x with whatever f of x is. So root x minus f of 1, which we already know is 1 itself, over x minus 1. And if you check, if you try and plug 1 in, we'll get 0 over 0, which is bad. So we need to do something here. And remember the conjugate, because I see a radical there. Come in with the conjugate, root x plus 1 on top, root x plus 1 on the bottom. Let's see what happens. Limit, x approaches 1. So when we do this times this, we just get x. The middles don't matter. Right, this and this cancel, and then we have -1 and +1. That multiplies to be -1 over the bottom, x minus 1. And I told you in class, don't multiply these out, leave them. And you can see here we get canceling there. So we get limit, x goes to 1. We have a 1 on top. We still have root x plus 1 on the bottom. And if you plug in 1 now, root 1 is 1, 1 plus 1 is 2, so this is just 1/2. We're not done. Now we need to use y minus y1 equals m times x minus x1. So y minus 1 equals 1/2 times x minus 1. So just replacing the m with this, replacing y1 with 1 and x1 with 1. Distribute the 1/2 through. And then add 1 to both sides. Y equals 1/2 x, and then when you put those together, you get plus 1/2 again. There's the equation. All right, let's look at number 6. Oh yeah, by the way, that was number 5. I had written 4 up there. Number 6, y equals 2x plus 1 over x plus 2. And the point that we're given is 1, 1. All right, maybe we should use this one again. Again, doesn't matter. Sometimes the algebra is better one way. So I'll try this one. I'm replacing a with 1. I think I'll move over just a little bit. This is equal to limit x approaches 1. Okay, let me try and go a little faster. What's f of x? Well, f of x, that's it right there. 2x plus 1 over x plus 2. What's f of a? Well, f of a is f of 1. And what's f of 1? It's this value right there, which is just minus 1. Then over x minus a is x minus 1. So here we have a complex fraction, so we're going to try and get a common denominator, which means I'm going to look at this 1 as being a 1 over 1, and then I'm going to multiply x plus 2 bottom and x plus 2 on the top, and then combine those two together. So when I do this, I'll have 2x plus 1 minus whatever this is. So I have to subtract each term, right? So minus x minus 2 all over x minus 1. This is the limit as x approaches 1. Oh, this is real nice. We get 2x minus x, that's x. 1 take away 2 is minus 1. And man, these just go away right away. This is just 1. So the limit is 1. And that's the slope of our tangent line. So now we say y minus y1 equals m times x minus x1. So y minus, let's see, y1 is 1 equals the slope, which is 1, times x minus x1, which is also 1. So this is just y minus 1 equals x minus 1. And if we add 1 to both sides, you get y equals x. Interesting. Interesting. All right. Now, number 7 is where we are going to start to try and generalize. All right. This is kind of leading us into the next section. If we have y equals 3 plus 4x squared minus 2x cubed. 3 plus 4x squared minus 2x cubed. We're trying to find the slope of the tangent line at the point where x equals a. So they don't tell us a point specifically. They're trying to get us to get a general answer. Say, okay, for any point a, what's the slope of the tangent line? So a in this problem is actually equal to just a. And I'm going to use, let's see, Let's go with the h to 0 this time. Let's try this one on this. All right, so notice I'm not going to be able to replace a with anything. I'm just going to have to leave it. So what I'll do first is I will replace into my function a plus h. So everywhere I see an x, I replace it with a plus h. I have 3 plus 4 times a plus h squared minus 2 times a plus h cubed. Nasty. Okay, minus, that's this, f of a. That means come in here and replace this with a and this with a, but subtract the entire quantity. So I'm going to do this in parentheses. It's that function up there, 3 plus 4, but replace the x with a, so a squared, minus 2, and then replace the x with a cubed. All of this over h. And I have a lot of work to do. Limit h goes to 0. All right, 3, okay, that's not bad. 3 plus, all right, 4 times this. 4 times, now what is this squared? I'm assuming you could do that on your own. Okay, so that's what you would get if you square that. Minus 2 times whatever this is cubed. So again, I'm going to assume you could do a plus h times a plus h times a plus h. You would get a cubed plus 3ah, sorry, a squared h, plus 3ah squared plus h cubed. That's what you would get if you actually cubed that. And then minus, I'll distribute the minus through, minus 3 minus 4a squared plus 2a cubed. All of this over h. That looks pretty ugly. Actually, it's quite beautiful. All right, keep it going. Limit h goes to 0. All right, 3 plus 4a squared plus 8ah plus 4h squared. So just distribute the 4 through here. Then distribute a negative 2 through. Minus 2a cubed, that's this, minus 6a squared h, here to here, minus 6ah squared, here to here, minus 2h cubed, and we still have minus 3 minus 4a squared plus 2a cubed, this entire thing over h. And I am hoping that the h will cancel. Well, I'm counting on it actually. So a lot of things are going to have to cancel. Let's see, 3 and 3 are gone. 4a squared and 4a squared are gone. 2a cubed, negative 2a cubed and 2a cubed. And everything else in here has an h. So I'm okay with that. Limit h goes to 0. All right. All right, okay, I'll write it. 8ah plus 4h squared minus 6a squared h minus 6ah squared minus 2h cubed all over h. Now, since everything in the numerator has an h in it, I will factor an h out. So I'm going to do this without having to rewrite the whole thing. Here I pull an h out. When I pull an h out, that h goes away. This h squared becomes an h. This h goes away. And this h squared becomes an h. And this h cubed becomes an h squared. Like that. And then those h's will go away. And at this point, I can let all my h's go to 0. So this doesn't have an h in it, so it's going to stay. This goes to 0, that's gone. This does not have an h in it, so it's going to stay. This has an h in it, so it's gone. This has an h in it, it's gone. And so the only thing left is 8a minus 6a squared. Now this is the slope of the tangent line at x equals a. Now the value of this is, if somebody gives me a value of a now and wanted to know the slope of the tangent line, I wouldn't have to go through the process again and again and again. I've done it once in general, so if someone gives me a now, I've got the slope. So I think that's what the next question asks, or the next part of the question. Part B, it says, find the equation of the tangent line at the points 1, 5, and 2, 3. So let's talk about this at 1, 5. 1, 5, and then at 2, 3. So at 1, 5, let's first determine what the slope of the tangent line is. The slope of the tangent line is going to be equal to, remember this now, I'm replacing the a with 1, right? Because that's the x coordinate. If I just replace the a with 1, we get 8. Let's see, 1 squared is 1 minus 6, we get 2. I know what the slope is without having to do all the work. And then from that, I can go to the y minus y1, which is 5, equals the slope 2 times x minus x1. And then from there, you can get y by itself. But essentially, we're there. We have the equation of the tangent line. And then if we want to do it again for a different point, like this one, a is 2, then we know that the slope of the tangent line is equal to, well, we just plug 2 in here. So 2 times 8 is 16, minus, let's see, 2 squared is 4. 6 times 4 is 24, so subtract 24. And that gives us negative 8. And then the equation of the tangent line is y minus 3 equals negative 8 times x minus 2. So just using that point slope formula again for each of those. The only thing that's really changed, well, a lot's changed. The slope is different, of course, and then your y1, your x1 are different. So 2 different equations for tangent lines because we are at 2 different points on the curve. But us working through this in general was ugly, but the benefit to it is that now we can start getting equations of tangent lines very quickly without having to grind out the actual slope every single time. Do it once, you don't have to do it again. All right, number 11. Don't you hate that when you look at your watch and then you realize that you didn't even look at your watch, so you look at your watch again? All right, number 11, it's a word problem. If a ball is thrown into the air with a velocity of 40 feet per second, its height in feet after t seconds is given by this equation. So they're telling us that a ball that's thrown into the air will be at this height, whatever we get, when we plug in t for time, which is in seconds. So after a certain number of seconds, this tells us how high the ball is off the ground. So at 0 seconds, the height is 0 feet. But if you plug in 1 second, 1 here, then you'll get what, 24 feet. That's how high the ball would be. Find the velocity when t is 2. So this is what we had talked about earlier in the class, that we're trying to find the instantaneous velocity, which is actually equal to the slope of that tangent line. So what we'll do is, I'm going to write down, we want the velocity at t equals 2. In other words, what they want is the slope of the tangent line at t equals 2. Which means that I can rewrite this as a function first. I'm going to call it f of t, not f of x. Notice that our variable is t. And then I can use either one of the definitions to come up with the slope of the tangent line. I'm going to use this one, limit, as h goes to 0. So this slope of the tangent line will be this. F of a plus h minus f of a over h. Now be careful, if you were going to use the other one, you would do limit as t approaches a, not x, of f of t minus f of a over t minus a. You'd have to replace all your x's with t's because that's our variable in the problem. but I don't need to worry about that because I'm doing it this way. So for us, when they say t is 2, it's kind of like them saying x is 2. This is our a. Right, so let me come over here. Remember, I'm not using that one. This is limit h goes to 0. All right, f of a is 2. 2 plus h minus f of 2 over h. Which is, this is just confusing me up here. Let's get it out of here. All right, we need to plug 2 plus h into this function, which means we replace that t and that t with 2 plus h. So that's enough room. Limit h goes to 0. 40 times 2 plus h minus 16 times 2 plus h squared. That's what we get when we plug 2 plus h into this function. Now I subtract from that f of 2. So let me plug 2 in here, all right, and see what we get. I'm just going to write it up here. 40 times 2 is 80, minus 2 squared is 4. 16 times 4, 64. Right, 16 times 4, yeah, 64. And then when you subtract these two, you get 16. So I get 16 all over h, which is equal to the limit, let me pass the 40 through, 80 plus 40h, okay, that's this and this, minus 16 times this thing squared, which is 4 plus 4h plus h squared. You do that on your own. Minus 16, all of this over h. Equals limit as h goes to 0 of 80 plus 40h. Distribute through here, minus 64, minus 64h, minus 16h squared, then minus 16, then all over h. And now cancellation hopefully happens. 80, take away 64, that leaves you 16, and then you take away 16, it's gone. Everything else here has an h in it. In fact, I can put these two together, right, and get negative 24h. So all I'm left with on top is negative 24h minus 16h squared. And I'm going to realize that I can factor an h out of the top. I'm going to do that now. H comes out. I'll be left with, I pulled an h from that, so negative 24. Pulled an h from that, so negative 16h. Then all over h. And there it goes. That's what I wanted. And now when you let h go to 0, that goes away. All you're left with is negative 24. Now, that's our slope of our tangent line, but how do I interpret that as a velocity? Well, remember, the height of this object was measured in feet, and the time was measured in seconds. So this right here, this instantaneous velocity, will be written as negative 24 feet per second. So at exactly 2 seconds, this object is traveling at a speed of negative 24 feet per second. Very nice. What was that, 11? Okay. 15. Man, there's still a lot more to do in this, I think. Let me see how much more I have. Whew, got a ways to go. Let me just try and finish up this page 81, and I'll come back and do more video later. So for 15, we have, for the function g whose graph is given, arrange the following numbers in increasing order and explain. Ooh, this one's going to be hard because I've got to draw this graph perfectly. Oof. All right, let me try this. Negative 1, 1, 2, 3, 4. So I know this point's here. It kind of goes up like this and goes up and then goes down like that. Okay, down at the bottom here. It looks like it bottoms out there just about here. Comes up and then goes up like this. That, okay, looks like it does that. And then they give you some values. 0, g prime of -2, g prime of 0, g prime of 2, and g prime of 4. All right, so this notation means the prime means the derivative means the slope of the tangent line. So I don't have a ruler in here. I'll just have to make up my own ruler. Here's my ruler. So let me start out. Oh yeah, and 0 is just the number 0. So let's look at the derivative at -2. So I come over here to -2, I take a look at this, and I try and imagine what the slope of the tangent line would be there. So it looks like the slope of the tangent line would be something like, here's the tangent line, right? And it looks to me like that slope is approximately 1, right? Because a diagonal line has a slope of 1, flat line slope of 2, line like this is a negative slope. A line like this would have a steeper slope, so it would be like maybe the slope of that's 2 or 3 or 10. Can't go vertical though, because vertical means that you have an undefined slope. So I'm going to say that this slope is approximately 1. See, this is where I don't know if my drawing is going to be good enough. All right, what about at 0? The derivative at 0. So I go to 0, and the slope of the tangent line there is going to have to pitch negative like this. Like that, I don't know. Looks close to -1. Yeah, approximately -1. Now how about at 2? Man. It's really hard to tell. This one right here, I tried to draw the best I could. I think that the slope here at 2, right here, I think that this line, from me looking at the picture, I think this line isn't as steep as this one. I think this one is steeper. So this one is kind of tilted down a little more. So I would say that this is approximately, I'm again estimating 0.8. It's not quite as steep as this one. And then g prime of 4, looks like if I go to 4 and come up here, the slope of that line is also positive, but it's even less steep than this one. So I don't know, maybe it's like approximately 0.4. I'm guesstimating here, and that's what they want you to do. So I just need to arrange these in order of what? Arrange these by increasing order. So from smallest to largest. So the smallest I would have would be this one. So I'm going to say this is my first one. That's the smallest, -1. And then 0, so this would be 2. And then 0.4, this would be 3. Then 0.8 would be 4. And then 1 would be 5. So those values are just arranged in order from smallest to largest now. The key to this problem is just to get you to be able to look at a graph and kind of have an idea of like at which points you have steeper slopes than other points. All right. Number 17. If an equation of a tangent line to a curve y equals f of x at the point where a is 2 is this, find f of 2 and f prime of 2. Okay, that's confusing. 17. Say if the equation of the tangent line to a curve, so you have some curve, they're not telling you what it is. And they're telling you that the equation of the tangent line, so the equation of the tangent line at a equals 2 is this, y equals 4x, y equals 4x minus 5. They want you to find where is that? F of 2 and f prime of 2. All right. so we have some curve out here, all right? 1, 2. Okay, we have some curve. I don't know what it's doing. But what I do know is that at 2, come here, the equation of this line right here is y equals 4x minus 5. Well, I can answer the second one right off the bat, this one. I know that this is 4. Now the reason why is because by saying f prime of 2, you're saying what's the slope of this tangent line at 2? Well, we already know the slope of the tangent line from the equation y equals mx plus b, which is what we're looking at here, that this number in front's the slope. So I know that the slope of the tangent line is 4. Now to find f of 2, that's a little more confusing, but you can think of it this way. This point right here, right, on this line, lives both on the curve and on our tangent line. So if I plug 2 into the black curve, the y value should be the same as if I plug 2 into the red curve. So plug in 2 for x, and this is 8 minus 5, which is 3. So the y coordinate here should be 3. So f of 2 is 3. That's it. 19. Sketch a curve that satisfies these conditions. All right. 19. So here are the conditions we have. F of 0, 0. F prime of 0 is 3. F prime of 1 is 0. F prime of 2 is negative 1. Let me start with that first condition because that's just algebra. F of 0 is 0. That point is there. The slope of the tangent line, the derivative, the slope of the tangent line at 0 is 3. So 3, oops, I jumped away from that like it was fire. Slope of 3, right, this slope of 0, slope of 1 is like this, 3 is like pitched up pretty steep. So I know that my curve when it comes through here is going to have a pretty steep tangent line. So when I draw it, you know, maybe I need to do something like this, okay? And then the derivative at 1 is 0. So if I go out here to 1, when I get there, wherever the point is, and it doesn't tell me where the point is, the slope at that needs to be 0, which needs it to be flat. So I'm just going to come up here and flatten it out like this. All right? And then the derivative at 2 is negative 1. So here's 2. I don't know where the point is, but I know when I get to it, the slope of the tangent line needs to be negative 2, which is pretty steep. So it's got to go something like, maybe like that. So I don't know, just go like this, like that. That's a function. F of 0, 0, the slope of the tangent line there is 3, pretty steep. I should have drawn that a little steeper. Maybe something like that. And then at 1, the slope of the tangent line is 0, and then at 2, the slope of the tangent line is negative 1. Man, I don't have time to finish all these. All right, that's a good place to stop.